Okay, so we ended the semester with a whole lot of unit circle stuff, right? Me drilling it into your heads, and we are not done with the unit circle stuff. Okay, so keep that in mind. We are switching gears a little bit before we come back to it. Even though this is all trig, the whole unit doesn't flow beautifully, but that's okay because this little sidebar here, I mean, it's all related, it just doesn't flow super great. This little sidebar here is just more time for us to practice the unit circle and make sure we really have it down for when we really need to use it some more. So we're going to switch back to degrees a little bit, but with the calculator. So we're still thinking radians on the stuff we have to know. So on your calculator, go ahead and make sure it's in degree mode. We'll talk about that again once we actually start pushing buttons, but it is going to need to be in degree mode for what we're doing, okay? All right. So previously, we learned how to solve a right triangle, okay? We will now look at how to solve an oblique or a non-right triangles. So what that means is when you learn trig in geometry, you're told you can only use this for right triangles. And honestly, we've used trig for circles and other things, but as far as solving triangles, we have only solved right triangles at this point. So we're going to look at how we can use trig to solve triangles that are not right triangles using what we already know. So we're going to come up with what's called the law of sines. So this triangle here, which is an oblique triangle because it's not a right triangle, triangle ABC, I want you to notice how it's labeled, because when we come up with rules and we have to use letters for things, obviously this triangle could be labeled DEF or whatever, and we could still use the same rule. So the important thing here is that you notice that the angles are the capital letters because they're points, that's how you name them. And then the side lengths are in lowercase because they're values, that's how it works. And if across from angle A is the side length A, across from angle B is side length B, across from angle C is side length C. Okay, so that way, that's what we're talking about in general here. So I want you to start by drawing in the altitude from point C to side C, little right angle there, which makes this the height. Okay, so that's the height of that triangle. So we're going to use the trig that we do know to come up with a rule that we can use now. So if I have, I'm going to find the sine of angle A. So if I've split this into two little right triangles. So for this right triangle right here, angle A, the sine is opposite over hypotenuse, so it's going to be h over b. So I'm going to start with the sine of angle A is equal to h over b. Then I'm going to solve for h. So to do that, I'm just going to multiply both sides by b. So that's going to give me h equals b times the sine of a. Okay, so I've solved for h. Now I'm going to find the sine of angle b. So the sine of angle b, it's opposite over hypotenuse, so it's going to be h over a. So I'm going to get the sine of angle b is equal to h over a. Then I'm going to solve for h. I do that by multiplying both sides by a. So I get h equals a times the sine of angle b. Okay. So I have solved for h on both of them. I'm going to do a little substitution. Since h equals a times the sine of b, I'm going to take this part right here and substitute it in for that h. So that's going to give me a times the sine of b equals b times the sine of a. Everybody with me so far? So now I'm going to divide both sides by little a. That's going to give me the sine of angle b equals b times the sine of angle a over a. Now I'm going to divide this little b out, so when I divide both sides by that, I'm going to end up with the sine of angle b over little b equals the sine of angle a over little a. So that uses only the side lengths and the angles of the oblique triangle. So it sets up a little proportion. And remember, what this is saying in general is I take the sine of an angle over the side length that's across from it. That equals the sine of another angle over the side length across from that one. So I could have drawn the height differently, and we could have used C in here too. And we could go through and do this for angle C, or you can just trust me that the same thing would happen. So we have this little proportion. This is our law of sines, basically, that we're going to be able to use, not having to use H and not having to have right triangles. Okay? So this says the law of sines can be used to find side and angle measures given two angles and only one side. Okay, so that means like this angle side angle or angle angle side. That should look familiar from when you did congruent triangles. Or two side lengths and an angle outside of them, and that's the SSA. We could not use that one to solve or to do congruent triangles because there's no ASA in geometry, right? But we're not doing congruent triangles here, but it's the same concept on how the information is set up. Okay, and we'll look at that when we actually look at number 1 here. And we're going to do these two today and this one tomorrow. So your notes today actually have 2 pages, but that's because I forgot to delete the second page. And so you can just ignore the second page. We're only doing the first one. So the actual law of sines looks like this. The sine of angle A over little a equals the sine of angle B over little b equals the sine of angle C over little c. You only use 2 at a time, but what it's saying is it doesn't matter which 2 angles, because that would be a true statement in the end. Okay. We all good so far? Awesome. All right, so now let's look at number 1. Now, obviously, so today's law of sines, we're also going to look at the law of cosines, so we haven't even talked about that yet, so it's pretty obvious what we're going to get to use on these. However, when you have a triangle, you're not sure which one you're using, you need to look at the information that was given to you. So what we know is we know these 2 angles and this side. So I have 2 angles and a side. This side is not included in the 2 angles. This would be the included side. So that's what makes this angle, angle, side. Angle, angle, side. And since it's angle, angle, side, I get to use the law of sines. So I look at what I have here. I have this 104 is across from the side length that's x, and I have this 47 that's across from the 15. Okay. So now I just set up my proportion. I'm going to take the sine of 47 over 15, and that's equal to the sine of 104 over x. And then we've been doing proportions for like ever, so this isn't that big of a deal. So I'm going to multiply both sides by x and 15. Basically, I'm cross multiplying. So I'm going to get x times the sine of 47 equals 15 times the sine of 104. Everybody with me? Just multiply through to get rid of those fractions. So now to solve for x equals, I divide by the sine of 47, so I get 15 times the sine of 104 over the sine of 47. Now is when you would actually use the calculator. You wait until the very end, right? And again, I don't care which version of a calculator you're using, just make sure it's in degrees. If you're not sure if it's in degrees, because some calculators it's obvious that it is because of the buttons or whatever, and sometimes you're not sure, just think of something simple. Like, for instance, what is the sine of pi 6? It's 1/2, right? What is pi 6 in degrees? Well, that's an easy one. What's pi 6 in 30? So if I just do in my calculator sine of 30, I know I should get 1/2. If I don't, then I'm in radians. Okay, so it's just an easy check. On an 84 type calculator, if you go into mode, you make sure you're in degree there. Whatever kind of calculator you're using, just make sure you're in degrees. Okay. One of the things that's better about the Desmos and Delta Math calculators is that when you type it in, it looks like what you write, where on calculators like this, it doesn't. Oops, let me take it clear. But either way, we're going to type this in. I'm going to have 15 times the sine of 104, close, divided by the sine of 47. Now, because of the order of operations and these calculators use them, I actually don't need to put my my numerator in parentheses, But if I had more than one thing in the denominator, I would need to. So it's kind of up to you whether or not you just do it all the time just in case, if you're not sure when they matter and when they don't, or if you do it when it matters. But, you know, again, I think it's safer for some people just to always put those in parentheses so that you're not confused about what you should get. But in the end, again, don't just write mine down. Type it in somewhere. Make sure you're getting these numbers. We should have 19.9006799, whatever. If you're not told, which you're not, I don't think, how many decimal places do we go to? 3, okay? The AP rule is 3 unless you are told otherwise. So my answer here is x equals 19.901 centimeters. Don't forget your units. What questions do you have? Anything? There's some on the very back counter. All right, number 2. You see it in this show? Like, walk straight back. Yeah. All right, so number 2. This one I have 2 angles and a side. This time the side is included, so that makes this one angle, side, angle. So again, I'm going to use law of sines. And it's really not that hard to tell if you're going to use law of sines or law of cosines, because either you can substitute the stuff in the right place or you can't. I mean, that's as easy as that. So I look here, and I've got this 42 degrees is across from x, which is what I'm looking for. But across from the 28, I don't have that angle. This 63 is across from a side that I don't know and I don't care about. So I don't really need the 63 to work this out, but I need that third angle to go with 28. Can I find the third angle pretty easily? Yeah. I add the other 2 up and subtract from what? 180. And what do we get? $75. Okay, so this is 75 degrees. So now I'm going to mark out 63 because I needed it to get to 75, but I don't want to accidentally use that number when I don't need it, because that is totally something I would probably do. You know, you just look over there and pick the wrong number. 75 goes with 28. So my pen just broke. So I'm going to have the sine of 75 over 28 equals the sine of 42 over x. Okay. So you go ahead and work that out and get your answer and all that good kind of stuff. Punch it in the calculator. Let me know if you have questions or if you're having issues with it. Not sure what to do. Please speak up. Any questions on that? Okay, and so I want to show you on the calculator. This time I didn't put those parentheses for the numerator, but your order of operations is to do multiplication and division in the order in which you see it. So it is going to multiply these before it divides. Whereas if I had 2 things multiplied in the denominator, it would divide and then multiply, and that's not what you want. So that's why I have to be more careful on some of those. All right, any questions at all right now? Awesome. So let's look at number 5, which is really number 3. So it says a pilot begins a flight traveling 80 miles northwest. To avoid a storm, he makes a turn, then returns to his original location. A diagram of his flight course is shown to the left. Find the total distance of the flight. Okay, so this time we're not just looking for a side length or something. We're looking for a total distance of the flight. And this one is all drawn and labeled for us, which is nice, but one of the things we're going to do in the next few days is we're going to have to draw some of these based on direction. And so make sure you know north, south, east, west, that sort of thing. All right, so and what it makes, that you can make sense of what's happening here. So we're starting here. He's traveling 80 miles northwest. He makes a turn, and then he returns. So that's what's happening here. Since we want the total distance, I need both of these side links to go with this 80. So I'm going to label one of them X and one of them Y, because those are my favorite letters to use. Yes. So since I need to find the other two sides, that means I'm also going to need that third angle. So if I have that 108 and 15, what does that make my third angle? $57, yes ma'am, thank you. So I get 57 degrees right there. All right, so now I'm going to find each one of these. But since I want the total distance, I'm going to put this over here to remind myself. Because have you ever known when you start a problem what you're supposed to do, but then you only do half of it and move on? I know you have, because everybody has, so don't even act like you haven't. My total distance, what that means is I want 80 plus X plus Y. Like I'm telling myself, hey, don't forget to add them up when you're done. So I'm going to start with X. So what angle is across from X? 108. And the more obtuse the triangles are, sometimes it plays with your mind. Like last period, somebody quickly said 80, and then he was like, oh no, that's a side length. So that's why I draw the arrows. As silly as they seem, sometimes it helps you like, okay, 108 goes with X, right? And then this 57 goes with 80. So it's a little bit more obvious and harder for me to mess up. So I'm going to do the sine of 57 over 80 equals the sine of 108 over X. So then I'm going to multiply to get rid of my fractions. I get X times the sine of 57 equals 80 times the sine of 108. So that means X equals 80 times, ooh, it would help if I wrote the right number. Okay, there we go. 80 times the sine of 108 over the sine of 57. And then I'm going to stop. I am not putting that in the calculator because one of the, there's good and bad, there's better things about all these calculators. One of the nice things about the 84 type calculators is how you can store information. It's not so easy on those other ones that type it in a little nicer. So we're just going to go with, we're not storing anything, and you cannot round in the middle of a problem. You have to be exact at the end. So that is my exact answer for X, and I'm going to leave it alone for a minute. Then I'm going to go find Y. So I'm still going to use this sine of 57 over 80, because that's the information I have. And then 15 goes with the Y, so I'm going to have the sine of 15 over Y. Then I'm going to solve for Y. So I get Y times the sine of 57 equals 80 times the sine of 15. So Y is equal to 80 times the sine of 15 over the sine of 57. So now the very last step is when we always touch the calculator. So I have an X. This is what I got for X. That's my X. This is my Y. And I need to do 80 plus X plus Y. So in my calculator, I can do 80 plus this plus this. Now, here's a little something I learned last period. Because I didn't actually type these into the Delta Math or the Desmos calculator, just because I knew it could work, but sometimes there's too much, I guess. So what you might have to do is make sure you know where the answer key is. Like you're never typing a decimal back in. But in the, someone was using they tried it on Delta Math and then on Desmos, and it just gave them like these 3 dots or an error, which made no sense. So if you do 80 plus this and get an answer, and then do answer plus this, like use the answer before, you can do it all in one step. Or if you have one of these calculators, we can just type it in all at once. So I'm going to do 80 plus 80 times the sine of 108, make sure you close those parentheses, divided by the sine of 57, plus 80 times the sine of 15, divided by the sine of 57. Okay. And again, I'm confident in doing this without all the parentheses because I know that that's going to use the order of operations. If you're unsure, the safest thing to do is use those extra parentheses. I mean, that's what it comes down to. So I get 195 point blah 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 there. So make sure you can get that with whatever calculator you're using, whatever you have to manipulate with. Now, sometimes in some problems, if you round before the very last step, you will get the same answer to 3 decimal places, but not always. So, and sometimes you don't when you think you will, and that's not a good thing for you. So make sure that you're careful with that. And the other thing is, I love Delta Math. I really do, because you get instant feedback, you get the help if you need it. I think it's wonderful. But one of the things, because we're doing so much on Delta Math, because of the nature of what we're doing, that we're missing out on is you actually writing out your answer at the end, and the other little nitpicky things which are important that we can't overlook and we can't get sloppy with. So at the end, like if this was a Delta Math question, you probably just have to type in the number. But if you're actually answering this question on any kind of exam, and it's not one of those kind of things, then you have to actually state what your answer is. You can't just, like this X and Y, I made those up. They weren't in there. So X equals whatever means nothing in this problem. It helps me, but in the end, I need to make sure that I say the total distance, and sometimes it has to be in a complete sentence, but it doesn't have to here. Total distance equals, and I get 195.409 miles, and I can't forget my units. Like that is my actual answer, all of that stuff. The work is important too, but any questions at all? Okay, so again, make sure that you can type this stuff in, that you're not just copying down what I'm doing. And if you're having issues with whatever kind of calculator you're using, let me know and I can help you with it. Like I'm really glad that girl said something last period, or I wouldn't know that there's issues with those other ones. Because I'm not going to try this on every single calculator that exists. Okay. Any questions? We all good? Awesome. Okay.